class 9th, we are going to discuss with your class today about triangles. The word triangles, tri means three, angles, of course you know what are angles, so three angles are involved here. A figure, plain figure, two-dimensional figure, bounded by three straight lines is called a triangle. A plain figure bounded, it's a closed figure. It is a closed figure bounded by three straight lines is called a triangle. Also, it is called a polynomial with three sides. Polynomial is a many-sided figure. I mean, they can be four-sided, five-sided, three-sided. It is a three-sided polygon. It is a three-sided polygon. In this, there are three angles and there are three sides, three vertices, where two arms, like there are three arms. What are the arms of the angle? AB, AC and BC are arms or sides of the triangle. BC, AB, AC. These are the arms or sides of the angle. They meet, two arms or two sides of the triangle meet at a vertex. They meet at a vertex. For example, BA and CA meet at point A. A is the vertex opposite to side BC. A is the vertex side opposite to A is the vertex opposite to side BC. So AB and AC are meeting at point A and forming the angle A. This is called angle A also, but generally angles should be represented by three alphabets. The vertices are generally, vertex is a singular, vertices is a plural. Vertices is a plural of vertex. So A, B and C represent the vertex or vertices of the triangle, which are always represented by capital letters, capital alphabets, A, B and C. Now if I have to write it is very important to understand because a lot of children make a mistake while writing angles. It is important to write angle correctly. Like if I have to write the angle at vertex A, how will I write it? I should write it as, vertex should always come in the center, like angle BAC. Angle BAC. It is the angle opposite to side BC. Vertex A, here vertex is A, and this angle is opposite to side BC. It is opposite to side BC. The middle alphabet in the three is the vertex, and at the other two ends, extremes, if we put them together, will make the side. BC is the side. Suppose I want to write the ACB. This means the vertex is C. Vertex at, here goes E, vertex here will become C, opposite to side AB. Opposite to side AB. If you see the side AB, opposite to this is angle C, ACB. Suppose I take ABC, angle ABC. Angle should be always written with the help of three alphabets, capital. It is opposite to vertex B. It is opposite to vertex here is B, and opposite to side AC. Opposite to side AC. It is very important to understand how do we write the angles. Angle should be written with 3 alphabets. Now, the side opposite to A, which is BC, the side opposite to A, like here, vertex A, the side opposite to A is side BC, which is also represented by small a, which is also represented by a small a. The side opposite to C is AB, and it is represented by small c. It is represented by small c. The angle ABC, now this is vertex B is opposite to AC. The side AC is represented by B. It is represented by B. Opposite to A, the capital A is a small a. The side is a small a. The small a means BC. B means AC. C means AB. It's very easy to remember. Like A is there, what are the letters left? What are the alphabets left? B and C. So side is BC. Here what is the alphabet? B. What are the alphabets left? AC. So AC is the side. Here the alphabet is small c. What are the alphabets left? AB. There will be 3 alphabets which will be representing any triangle. If I have taken the ABC as the name, you can take PQR, you can take anything. That doesn't matter. X, Y, Z, LMN, PQR, whatever you want to take. This is just convention to take the ABC, but you can take anything, it does not matter. So vertex, vertices, side, angle. Now it is also important to understand that sometimes you write angle A also. BAC can be written as angle A, ACB can be written as angle C, ABC can be written as angle B. But the question is, when you come across, here only one vertex is there. At A only one angle is formed. At A only one angle is formed, and that is why you can represent it by single alphabet. But suppose there are more than one angles are formed. Suppose it is A, B, C, and it is D, or maybe write E. So I cannot write angle A, because if I write angle A, which angle am I talking about? If A is here, which angle am I talking about? Am I talking about this angle 1? Am I talking about 2? Am I talking about 3? Am I talking about 4? Because 4 angles are formed at point A. Here only one angle is formed at A, that is why you can represent it with the angle with single alphabet. But suppose the figure is like this and 4 angles are formed at A, then I cannot write this angle as A. I'll have to specify what are the angles. For example, it could be BAC, it could be BAC. BAC is angle 2. Suppose I want to write 3. What is the angle 3? DAC. Vertex should always come in center, because at A I am forming the angle, A will come at center. Fourth, what is the fourth angle? Fourth angle is EAD. EAD is the fourth angle. And what is the first angle? EAB. So it is always safe to write an angle with the help of 3 alphabets instead of writing it as a single alphabet like A. When there is only one vertex, there are not more than only 2 straight lines are meeting at a point, only one vertex is there, it's okay, you can write it as angle A. But here to mention simply with the alphabet A will be not correct, because there are 4 angles formed at A and they are all different. So which angle are we referring to? That is why it is important that we write with the help of EAD or DAC or BAC or BAE. But one thing you must see, that the vertex A is in the center. Vertex A is in the center of each of the angles. That means at A the angle is formed. At A the angle is formed. Now we have discussed vertices, vertex, sides and arms, angles we have discussed. Now let us discuss the kinds of triangles we come across. The kinds of triangle. The division of triangles is done on the basis of sides, length of the sides, and angles. First, we'll discuss on the basis of length of side. First is scalene triangle. Now suppose triangle ABC is there. In what conditions triangle ABC will be scalene? If all the three sides AB is not equal to BC is not equal to AC. Suppose all the three sides are of different measurement, of the different length. For example, I will say AB is 4 centimeter, BC is 5 centimeter, and AC is 6 centimeter. If the measurement of all the three sides of the triangle are different, like I have taken AB is not equal to BC is not equal to AC, AB is 4, BC is 5 and AC is 6, then this kind of triangle is called a scalene triangle. It is called a scalene triangle. Second one is isosceles. S-C-E-L-E-S. Isosceles triangle. A triangle in which two of its sides are equal. Suppose AB is equal to BC. Suppose I have a triangle A, B and C. Suppose AB is equal to AC. AB is equal to AC. Suppose it is 5 centimeter, it is 5 centimeter and it is 4 centimeter. This kind of triangle where two sides of the triangle are equal, it is called an isosceles triangle. It is called an isosceles triangle. And base angles of isosceles triangle are always equal. Base is the third side, which is not equal. The side which is not equal is called the base of the isosceles triangle. For example, here AB and AC are 5 centimeter each and BC is 4. So BC is the base. The base angles are equal. The angles opposite to equal sides are equal. In another way, what I can say is that AB opposite to AB is angle C, opposite to AC is angle B. So angle B and angle C are equal to each other. So in an isosceles triangle, the base angles are always equal. AB and AC are equal. Opposite to AB is angle ACB. Opposite to AC is ABC. So these are the angles which are equal. If sides are equal, then the angles opposite to them are equal. And in an isosceles triangle, two sides of a triangle are equal and the angles opposite to them are equal. The third one is equilateral. Equilateral. E-Q-I-L-A-T-E-R-A-L. Equilateral triangle. In equilateral triangle, all the three sides are equal. A, B, C, 6 centimeter, 6 centimeter, 6 centimeter. I've just taken an example. You can take, the sides have to be equal. In equilateral triangle, if all the three sides of the triangle are equal, AB is equal to BC is equal to AC. Suppose I am saying 6 centimeter. If AB is equal to BC is equal to AC and all the three sides are equal, it could be 6 centimeter, it could be 5 centimeter, it could be a centimeter, then the triangle is called an equilateral triangle. And another property, important property is that all the three angles of the triangle are equal. For example, ACB will be equal to BAC, will be equal to ABC, will be equal to 60 degree. Each angle will be 60 degree. Whatever may be the side, 6 centimeter each or 5 centimeter each or 10 centimeter each angle of the triangle will be 60 degree. It could be 6, 6, 6, even then it is 60. Whether it is 7, 7, 7, then even it is 60. If it is 5 centimeter, 5 centimeter, 5 centimeter, If all the three sides are equal, then the three angles will be 60 degrees. In an equilateral triangle, all the three angles of the triangle will be equal. That is also one of the definitions of equilateral triangle, that if all the three angles of the triangle are equal, then it is an equilateral triangle. So this was the division on the basis of the sides. We said no side, all the three sides are different. AB is 4, BC is 5, AC is 6. I have just taken an example. It could be anything. In general, it could be A, B and C. A centimeter, B centimeter, C centimeter. That means A is not equal to B, is not equal to C. That is all. In isosceles triangle, I am saying AB is equal to AC. Not necessarily that AB should be equal to AC. AB can be equal to BC also. That will be all right also. Or BC could be equal to AC. That will be all right also. So it doesn't matter. If two sides of a triangle are equal, it is an isosceles triangle. And if all the three sides of a triangle are equal, then it is an equilateral triangle. Then it is an equilateral triangle. Now let us do on the basis of angles. It has to be done on the basis, we did on the basis of sides, now let's talk on the basis of angles. First one is acute angle triangle. Acute angle triangle. ABC is any triangle. If angle ABC is less than 90, angle ACB is less than 90, and angle BAC is less than 90. That means each angle of the triangle is less than 90. If each angle of the triangle is less than 90, then the triangles are going to be equilateral triangle. That means each angle has to be acute. Acute is what? An angle between 0 and 90 degree. Angle between 0 and 90 degree. All three angles have to be acute. All three angles have to be acute. Then the triangle is going to be A, acute. I would say acute, acute and acute. If all the three angles are acute, then it is called an acute angle triangle. Then it is called an acute angle triangle. Next is right angle triangle. A triangle in which one of its angles is right angle. Only one angle will be, it is only possible to have one angle of a triangle to be right angle, like ABC. If angle ABC is 90 degree, angle ABC is 90 degree. If one of the angles of the triangle, only possibility is one angle can be only right angle. So if one angle of the triangle is a right angle, it is called a right angle triangle. The sum of these two angles will be 90. The sum of the remaining two angles will be 90. That means they will be acute. They will be acute. They will be less than 90. Only one can be 90. The remaining will be less than 90. It is called a right angle triangle. It is called a right angle triangle. And in this, the biggest side is AC. The opposite to 90 is called the biggest side. Opposite to angle 90. Angle 90 is the biggest angle in this triangle, and this side opposite to 90 is called hypotenuse. It is called hypotenuse. It is called hypotenuse. It is important to remember that the side opposite to right angle is hypotenuse, and it is the biggest side of the right angle triangle, because bigger the angle, bigger the side opposite to it. Because these two angles will be less than 90, so obviously the other two sides opposite to them will be smaller than hypotenuse. Hypotenuse is the biggest side of the right angle triangle. Then the third one is obtuse angle triangle. If one of the angles of the triangle is obtuse, only one possibility is there. Only one angle can be obtuse, not more than one, because then construction will not be possible. The triangle will not be possible. It is more than 90. It is more than 90. One angle more than 90. ABC is, suppose I have taken this, greater than 90. They all have to be less than 90, whatever I write. Have to be less than 90, acute. They have to be less than 90. ABC has to be less than 90. ACB has to be less than 90. BAC. ABC, if it is greater than 90, then it is obtuse. For this, acute. ABC has to be less than 90. Then only it will be less than 90. ACB less than 90. BAC less than 90. Then they will be acute. By mistake, I had changed sign. Here it is obtuse. ABC is greater than 90. It is greater than 90. Any angle which is greater than 91, 92, 93 till 180, below 180, 179 or even greater than that, but less than 180 will be an obtuse angle. So one angle is obtuse, the remaining will be acute. The remaining two angles will be acute. They cannot be obtuse. Only one angle can be obtuse. Only one angle of the triangle can be obtuse, then it is called an obtuse angle triangle. It is called an obtuse angle triangle. There are certain other terms which are very important for triangles. First is orthocenter. Suppose ABC is any triangle, it could be any kind of triangle. If I drop a perpendicular from the vertex to the opposite side, for example, if I drop a perpendicular from A to BC, suppose this is P, AP is perpendicular to BC, AP is perpendicular to BC, this is called altitude. It is called AP is called altitude. It is called altitude or altitude, whatever you want to call it. Altitude and altitude. This is altitude. Similarly, if from vertex B I drop perpendicular onto AC, then I'll get this. This is B, Q is altitude. And if I drop from C, this is CR is altitude. Now all these perpendiculars drawn from the vertex onto the opposite side of the triangle are concurrent at a point, which is called H, which is called orthocenter. It is called orthocenter. It is called orthocenter. The point of concurrency of the altitudes of the triangle is called orthocenter. It is important to remember and understand that if I drop perpendiculars from the vertex to the opposite sides, then we get altitude. AP is the altitude corresponding to vertex A, BQ is the altitude corresponding to vertex B or side AC, and CR is the altitude corresponding to vertex C or side AB. And all these three altitudes are concurrent at a point which is called orthocenter. Now next is centroid. PQR is any triangle and L is the midpoint of this. QL is equal to LR. M is the midpoint here and N is the midpoint here. L is the midpoint of QR, M is the midpoint of PR and N is the midpoint of PQ. And if I join these midpoints to the vertices, we'll find that all the three lines PL, QM and RN will be concurrent at a point called G. It is called centroid. They are concurrent at centroid. And please understand, these PL, QM and Rn are called medians. They are known as medians. A line segment joining the vertex of the triangle to the midpoint of the opposite side is called the median. A line segment joining the vertex of the triangle to the midpoint of the opposite side is called medians, and medians are concurrent at centroid. Medians are concurrent at centroid, and centroid divides the line median in the ratio of 2:1. 2:1. That means PG is to GL is 2:1. QG is to GM is 2:1, and RG is to GM is 2:1. The side towards the vertex is larger. The side towards the vertex is larger. Side towards the base is smaller. So the medians are concurrent at centroid, and centroid divides the median in the ratio of 2:1. This is a very important thing which you will be coming across all the time again. Centroid. Then incenter. If I bisect the interior angle, if I bisect this interior angle, they'll meet at a point. And if I join this point to this point, that will be also the bisector of angle A. So the bisectors of the interior angle meet at a point which is called I, which is called incenter. It is the center of a circle. If I take I as the center, and I'll tell you how to draw it later, but if I draw a circle, that circle will touch all the three sides of the triangle inside, and it is called incenter. What we do is we drop a perpendicular from here to here, and this distance is the radius of that incircle. With taking I as center and suppose IP as radius, we draw a circle. That circle will touch all the three sides of the triangle inside. This is called incenter. This is called incenter of the triangle. Orthocenter, centroid, incenter.